Alright, welcome back, Generals, to another Let's Fix the Generals 0 hour to make the best game ever. We are still in the middle of the unassemblize fixing. I have privated a bunch of videos before this one here, so they are no longer available. Maybe I will private videos in the future again, so you better watch straight away. Yeah. Okay, so last video, well, it's private now, so you will just watch this. Okay, what do? We will. What do we do? All right, so we did some improvements here for executable. We handed over the PDB symbols for the executable. Okay, so there was one more thing. Like, do we want to overwrite the symbols? Do we want to overwrite the symbols or not? That is a good question. Did we actually commit already? Yeah, everything's committed. Yeah, so the question is, do we overwrite or not? So let's add like a Boolean overwrite. Bool overwrites. Let's put that on false by default. Bool overwrites. Then we also need it here, overwrites. So bool overwrites, and here. Okay, and then we need to pass this here and here. Okay, so if we overwrite, then what do we want to do? Basically, okay, so it finds if it's not existing. Okay, so and then we should say here else if overwrites, yeah. Then we say symbols dot, well, we say it equals symbol. Well, that doesn't work. Xe symbol. Why is it not working? IT is second. Hold on. M symbols second this way equals symbol. There we go. So this is the index. IT second C. Or is it not? Hold on. Address to index map, yeah. So this is the index symbol. Yeah. So if we overwrite, then we overwrite it here. Symbol. What's the problem here? Okay, so this add symbol, where's it called? Load symbols. I think here we should pass it through. Well, I'm not so sure. Let's keep it default. Okay, so here we have add symbol. Now the question is, do we want the PDB symbol to overwrite the existing? Maybe. Load. Overwrite sections. Oh, I don't know. Add symbol. Maybe true. Okay, so basically I see. Main exe. Well, the problem now is, so here we read the executable first. So it already populates some symbols that it can get from the executable. Then it adds our symbols on top, so it overwrites some of the symbols, and then it loads a config, and then it overwrites symbols again, all of them from the config. So it's a bit confusing. Yeah. I don't know. Yeah, so basically the config takes precedence over PDB, and PDB takes precedence over exe. Maybe we should document this. Symbols. Symbols in. Well, how about here on load config? We have here overwrites symbols. False. Bool. I put that here. Overwrite symbols. And then load symbols. We pass that here. Then we go to this function. And then we also overwrite symbols. And then we pass that here. And then we pass that here. Bool. Okay, so we have control over this now. exe options. Yeah. Let's put const export bool. PDB symbols overwrite. PDB symbols take. See, PDB symbols overwrite exe symbols. How about that? And config symbols overwrites exe PDB symbols. Okay, I think that helps. Okay, now we put that here. So put this here and we put this there, and now it's explicit. We don't need comments. PDB symbols overwrite executable symbols, config symbols Let's call this CFG. Override exe pdb pdb symbol. Actually, we need to rename this to pdb symbols overwrite exe symbols, and this to cfg symbols overwrite exe pdb symbols. Yeah, okay. Okay. So config symbols take precedence over PDB, and PDB takes precedence over exe. Yeah. That's a deal right now. Okay, let's debug if this actually is true. So we need to change this. Projects, assembly, and unassemblize solution, debug. Let's delete some of the files here. Debug, I have no idea what that is even. Okay, so we need game dot Thyme dot s dot but. What happened? Debugging. This apply, okay. Run this. Okay, so we have this 1337 symbols. So symbols, so we already have 57 symbols here. Initialize critical section and so on. Okay, so now we increase the size. Yeah. Okay, and now we go through these guys and we have a name. Sabotage that. Override true. Okay, let's put a breakpoint in here to see if that hits. It does. So we have a symbol, the interlocked increment. Yeah. And now it overwrites it. So we have symbol 4. This one is currently this. And it will be overwritten with that. And that gives us a size because PDB has size in there. Great. Add symbol. Great. Okay, then this works. And then we can repeat that until loads config. Okay, now it will be interesting if load config then overwrites what PDB is written, and I think it will. Let's see. So we have load symbols here. Add symbol. So let's put the breakpoint back in here. No, it doesn't overwrite. Okay, because we don't have a config, right? Thyme Oh, we do have a config. What is in there? Let me search for initialize critical. Not found. Critical section. Okay. I don't know what's going on with that. Okay, yeah, well, let me put let's debug this once more, just to see if it gets passed down properly. So this is true. Override symbols is true. Ah, it skips it because it already has symbol section. Section. Okay, so it will only overwrite if we do, overwrite symbols or that. Well, hold on, I'm a bit confused. Yeah. J. So we have read this JSON file. Could be. I'm confused. So it doesn't somehow find symbols. Oh, right. Okay. It's right. We never dumped Thyme.config.json with symbols. Okay, so it's not in here. Then it's fine. That's why it doesn't find it. Okay, no, then it's correct. Good. Then that means we can submit that. PDB symbols override exe symbols. Okay. override, load config, override symbols. Yeah, this looks good. This is good. Yeah, all good. Okay. Add functionality to override. Add functionality to override exe or to override symbols. To override symbols with different data sources. Yeah. Override symbols with different data sources. Okay. Good. Yeah, let me push latest. I think this already is pretty good. We can push it. I pushed latest the branch. Okay, so now we need to think about next steps. So we now have PDB reading in order. It's delivered to executable. We do have function with Zydus operation, Zydus instruction generation. We have all the foundations to think about how do we do the comparison now, and how do we feed the comparison. So right now the tool only wants to process one thing at a time. We needed to change it so it can read two things at the same time, that's for sure. So it reads two things so it reads two executables, two configs, PDB, whatever. It loads it in, but it doesn't, I think, like the starting behavior should be that it doesn't start processing everything. So right now we have it set up to, well, with a command line argument, we have set it up to like start at the first section begin and end at the section end, right? So it just go through everything. Okay, but it shouldn't be like this. Instead, we need a GUI, I think. We need a GUI. We need to a GUI that gives us like the bare bones intel. Hey, here, what do you want to compare? Here you have these options. What do you want to do? So, okay, but before we start GUI, we still need to do non-GUI work for all the comparison work. Yeah. Well, we could also start with GUI. I don't know. I need to think about this. What's the time? Just 30 minutes. So right now, yeah. 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 Yeah, we need to seriously think about how the flow should be done. So right now it's only catered to one thing at a time, right? You have a start address and an end address, and on its way it does everything, right? It reads all the PDB stuff, reads the executable, it reads everything, even if it only needs to inspect a small thing here, right? It reads all the JSONs, everything, it populates everything, even though it is not strictly necessary. So okay, it won't be easy to get started, but I think once we are in the middle of it, it will be easier. But right now, it's not entirely clear how we start this now. We have a lot of pieces now, but how do we go from here? So I think the first thing we definitely need is input. We need two file inputs. Yeah. Okay, I think my goal for now is just to figure out how we proceed. So we do need a program routine where we say, hey, everything is loaded in. Program is running now. Everything is ready. Now please give me. Yeah, there need to be different steps. So so right now process exe and process pdb, they have all this load config, add symbols, blah blah, and then they have this disassemble function stuff down here, and this needs to be decoupled. So basically we load everything once, yeah, and then afterwards we can then disassemble multiple functions as we please. Yeah, I think this is how it should work. Yeah. So we need something like load exe and then afterwards disassemble function, something like this, right? For PDB we don't. PDB, we just process PDB, yeah, that's it. Just nothing else to do. Okay, but process exe needs to be split. Runner. Okay, on that note, I think it would be good if we move the runner class into a new file as well. Because like it shouldn't be in main. Main is just our starting point. But I suspect that the runner class will probably grow in complexity. Yeah, I think so. Okay, I think this is already a good idea. Yeah, we move it and we split process exe. And then, yeah, and then what's the next step afterwards? Then we need to okay, let's put here some to do so we know what to do. So to do, move to new file. Yeah. Here to do split into two functions. Load exe and disassemble functions. Yeah. And yeah, and then the runner will basically here second move to new file to do provide functionality to provide functionality to select functions to disassemble. Provide function to select functions to disassemble from two sources. Right. And then we probably also need functionality to select functions to have two sources. Functionality to have two sources. Two exe sources. And then functionality to discover or to discover discover functionality to discover the functions to discover matching to discover same functions on two sources, right? And then we need to do facilitate matching. Function is matching, right? So basically the runner, so the runner should allow us to say, okay, we want to, I pick this function, find me the one on left and right. on both sources. Now I want to disassemble these, so it does that, and it saves the disassemble data, which is the function class. And then it can pass that to the ASM matcher class. So there will be a new class, class let's call it ASM matcher. I don't know. ASM matcher. Why not? Right. So, and then the ASM matcher would do like a comparison with the data it gets from function, the instruction data, and would try to find differences between left and right, and then like generate the results for the diff. Yeah. And then once the matcher is there and can generate the results, then, and we have all the logic in place to facilitate the diffing and everything. I mean the disassembling and the diffing. Then we can think about having a UI for this, right? But we first need the fundamental functionality. Yeah. Okay. So that's a lot of stuff to do. Yeah. Okay. But I think this is the right course. So the main function gives us the command line arguments. There we would then also pass like a GUI option. But for now, everything we just control with command lines. Okay. We have to provide two sources, Thyme.pdb and game.dat. These are our two sources, left and right. That is passed to the runner, and the runner can have two sources, A and B. And then it will try to find, it will build it will build like a hierarchy. So discover and organize So I think we need something like I think we need something like let's type it here. Like struct. How do we say? Discover and organize, same functions on two sources. So I need to think about this. Discover and organize. So, okay, so there will be something like function match, something like this, yeah. And then there will be address left and address right, right? So will be address 64T right? So there will be something like this, left and right. And then we can also have function match. And then we can also have struct file match, or let's say, let's not call it file match, let's call it collection function bundle match. And in there will be a std vector of function match. Functions. And then here, this is, yeah, well, it's self-explanatory. Yeah. So the motivation is we will have, so it try when we have a PDB, when we have two sources, it will try to match. It will try to match the symbol. So it will find matches. So the symbol A, and it's present in executable 1 and in the executable 2. We know about these. Okay, they are match. So we then can store here those addresses. And with the addresses, you can look up the symbol information, right? And then we have a function bundle match. This is when we say, hey, I know that functions belong together in a certain group. There is a file, and in all of this file, there are these functions inside. So that's the bundle or compound or however you want to call it, function bundle. So combines, not compiles, combines functions from same compilant or CPP file or CPP. Okay. And this is finds matching function from two sources. Function address. Yeah. Okay, and with this information, when we have this, we can then basically, well, first we can say, okay, you have this, process them all and compare them all automatically, right? If we just use command line, find them and compare them, match them, right? So that would be the first. But then also with GUI, if we have a GUI, we can say, hey, all these things are available, and you can disassemble them and compare them. And then it will work through whatever you selected. And then maybe there's a button to like recompare. Like let's say the executable has updated, yeah, and then you want to reload, then you can just rematch again, right? Refresh, stuff like this. Okay, but first it would have to work with a command line. Yeah, everything has to work with a command line. So we can implement all this without UI first. Yeah. Okay, so this will be quite a bit of work. Yeah, but I think that makes sense. So the runner gives us all, it combines all the things. It collects all the symbols from the PDB, from executable, from config, and so on. It loads all the stuff. It has it prepared. And then it discovers the links between these things. Yeah, and then And then we need a class to match the stuff. So once we have this here, the bundle match with the functions, then we can start creating function class objects for these things, for these addresses, symbols. And then yeah, we generate the instructions out of these. And then we pass these things to the ASM matcher, and the ASM matcher creates a result. And the result can then be dumped into a file as text, or it can be passed to the UI for printing, whatever, right? Yeah. Yeah. Okay. Yeah. Okay, that's a plan. That's a plan. Let me comment this. Let's put a *1 here. *1. Okay. Okay, good. Okay. Yeah, that sounds like a good plan. Okay. Yeah. Do we expect any troubles? Do we expect any troubles? Not really. Can't think of anything that would be tricky here. I mean, we need to come up with good algorithm for the comparison, but it shouldn't be too hard. It's just some text comparison. Yeah, I think the ASM matcher should be straightforward. Yeah, it's basically just a lot of monkey work to implement this. I can't think of a very challenging problem. We need to figure out how we do the UI then. But basically, the UI should then just interact with the runner, right? Yeah. Should just interact with the runner. Yeah. Okay. Yeah, I think that's a good plan. There probably is still some unknowns, but we will figure this out on the way. Yeah. Okay. Then yeah. Good. Let me also write an update here. Next plans. Move runner class to separate file. Add functionality to have next steps for unassemblize. Move runner class to separate file. Add functionality to have two exe sources. Add functionality to have two sources. Add functionality. Add functionality to discover and organize same functions. And organize same functions on two sources. Facilitate ASM matching. Add UI to interface with runner class and give commands on top of command line. Yeah, so these are the high level steps. Yeah, so I think this will be easy. This, yeah, will be step. Should be also fairly easy. This one, yeah, we need to see what should be okay. Then this one will be a bigger task, I think, with the ASM matching, and UI should also be a big task once we have all the other things ready. Yeah. Yeah. Okay, and our function, so the changes we did to function, which I've showed in now deleted videos, is suitable for what we want to do. So basically, what we can do, like once we have a function and we have it disassembled, we can store this whole function thing, or just the instructions results. Yeah, that or that. On that note, maybe, let me see the begin address. Get begin address. Disassemble. Yeah. To do move to function intermediate if not needed here. To do remove if not needed at all. So there's a case to make that perhaps we don't need to. Perhaps we don't need this information here persistently. Then we just move it into our intermediate. And this one remove. Then we save another 8 bytes here. Yeah, could do that. So basically we would have like function symbols. And for function symbol, like here on this, let's go to main here. Like if we have like a function match, then we could also have here like function left, right, and function right, right. And so here we already have the address to the start of the function. Then we don't need it inside here anymore, right? And then here we would have this, and when we call disassemble on this, and then we have the instructions ready, and then we can use the instructions to pass on to our ASM matcher. It's also possible that maybe we want to discard this whole thing and only use a temporary if we really only care about the string here, the append as text, right? So we have an empty string and we just generate the text out of the instructions. But I think for ASM matching, we actually want to use this here. We don't want to use plain text because this gives better data to compare. Like we can ignore the label, for example. We can just look at the instruction and we can compare the jump len if it's a jump, and maybe there will be additional metadata in the future here for this thing, right? So I think this should be ASM matched, not the result from this. Yeah, that makes sense. Yeah. Okay. Good. We have a plan. It will be quite a bit of work, but yeah, so far so good. We did good progress. Yeah, we have how many changes already? Quite a lot already. Yeah. Every day a little progress here. Yeah. Yeah, last days have been very productive here. That's good. Very nice. Okay, good. Then, yeah, I will take a break now. We have a plan. I wish you a great day or night. Until next time. Goodbye.